All right. So let's get the average number of flips until we see both sides. Now the reason I just gave you guys a deck of cards is we're going to repeat this experiment with cards. Number of draws until the repeat, number of draws until we see all the sides. It's fun data. It's fun data. See both sides. I never gave you technology. Do the same thing with dice, which would be prohibitively long to do with an actual die. So we'll use computer technology to simulate it for us. All right, anyway, getting ahead of myself. Here we go. I got to go 2 plus 2 plus 2 90 times. That sucks.
90.
So I'm going to do 2 times 90. Exactly, or 90 times 2. I love that too. 90 times 2 plus looks like 35 times 3. 4 times 30. 5 times 9, or 9 times 5, I guess. I should be consistent with how I'm writing this. Let's do 30 times 4. I'll always put the frequency first and the number second. How's that sound? It doesn't matter. I mean, it's commutative, but just so it doesn't confuse anybody. I'm going to be a little bit illegal now and bring the line down to the next line because I'm running out of space. 11 times 6. 5 times 7. 2 times 8. You can skip the 9. Because 0 times 9 is 0. It's not going to contribute anything to the total, right? Is that fair? So you just leave it out? Because it was 0. Now the 1 times 10, definitely leave that one in. And the 11 you can skip because it doesn't contribute anything meaningful to us. And then the 1 times 12. Let's make sure, stop right here and make sure you guys know why we are multiplying and why we're also adding. There are 2 operations going on, multiplication and addition. Let's make sure we buy both of those things as to why we're doing it, okay? Why are we multiplying? Why does multiplication make sense?
That's the flips. That's how many.
Do we have to use multiplication if we really hate multiplication? Could we just not do the multiplication?
No, but could add.
We could, and just add 2 90 times.
Right.
2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. And exactly. Tiffany's like, no. Even in Minnesota, we don't do that. Good. So we do 90 times 2, which is why we invented multiplication in the first place. Good, yes? Good. Excellent. Why are the additions here, then? I don't understand why they're there.
The total number of flips.
Because they need to be? That's a very good answer. Because if you don't do that, you're wrong. That's a very good answer.
They teach us.
Why can't I go out on Friday? Because I said so. The reason is you have to add everything up. You have to add all the data up. So, I mean, theoretically speaking, there's a lot of addition signs in this. We've just broken down the ones that are redundant with multiplication signs. But that still means we have to add the 2s and the 3s and the 4s and the 5s. So that's why the addition signs are there. Beautiful! What goes at the bottom?
How many? 15?
Yes, ma'am. Ah, careful. 184. Because you guys did 184 total experiments. Now there are 14 actually. There are 14 outcomes. But you don't want to divide by 14, because if you divide by 14, it makes it look like you only did 14 experiments. You actually did this many experiments. Think about it this way. If you actually wrote out every single one of these 2s, and every single one of these 3s, and every single one of those 4s and 5s, you'd have 184 numbers up there. And that's when you do an average. Brittany, I know you told me this 2 weeks ago. When you calculate an average, you add them all up and divide by how many there are. And that's how many there are. 184. So, and I know it looks a little bit weird, but there are 184 discrete numbers up here. Is that fair enough? It's also the sum of all these coefficients, all these frequencies, which is how many data points there are altogether. Cool? You guys get very quiet. Is that okay? Tell me if it's not. Tell me if it's not. Oh, it's okay. Okay. Sometimes you get quiet because, okay, just checking it. Oh, I know it's early. I'm yelling. So. Okay. What's it come out to be? I don't know. I can't do this in my head. 3.2?
Yeah.
Marion's got it. Christina's second. I'm going to trust you guys.
5 was pretty close.
5 was pretty damn close. 3.14. Not a bad guess. Just, I offer a suggestion if you're using your calculator to do this calculation. Let me show you real quick.
Yeah.
That's exactly why I want to stop. I want to pause for a moment and I want to run it through with the machine to make sure we see how to get the